Hello, everyone. Thank you so much for joining our office hours today. Pleasure to have you all. Today's office hours will focus on transforming document processing in healthcare. My name is Jonathan, and I'm a senior solutions engineer here at Infinix. And today we are joined by Natalia Arzeno. She's our Chief Data Scientist for Infinix. So I'm happy to get right into it. So Natalia, do you want to briefly say anything before I open up?
No, thanks for having me. I'm excited to talk about this topic.
Awesome. I'm excited to talk about it too. So first question is, what is document understanding and why is it an important problem in healthcare?
Yeah, so document understanding at a very high level, it's extracting useful information from a document. Now, that can mean many things. So the term document understanding can be used as an umbrella for more specific tasks. So we can be categorizing documents, understanding what's the type of document, or extracting specific text from a document. So maybe specific information that we care about. But the main idea is that we're taking unstructured data, which is data that is free text or images, and outputting structured data through this document understanding process. So, and this is structured data would be data that can be organized in some tabular form or can be later used for some other purposes. Now, the way that we can achieve this is via some machine learning techniques, especially in the area of natural language processing, or NLP, which is a very key field for document understanding. Now, NLP deals with text. So I mentioned images just a bit ago as an example of unstructured data. So if the documents are also of varied structures and layouts, then we go into the computer vision field as well. So document understanding will encompass both NLP type algorithms as well as computer vision models. Now, document understanding becomes relevant for any process where you receive documents and you need to identify some key information in order to continue to the next step of a process. So, for example, documents may need to be sorted into different categories for more efficient processing. And I mean, Gmail does this for us. It sorts incoming emails into different folders. That way you can prioritize what you look at. But in other processes, maybe you don't need to know what type of document it is, but you need to be able to extract key information, so certain names or amounts, perhaps from invoices, in order to either correctly file the document or be able to input this key information in some tool. So by achieving this goal of information extraction, this document understanding process can help in reducing manual efforts and also human errors. So the computer will not be committing typos as it's entering information. And it also allows for scaling these applications and processes, since the computer can act way faster than a human can. So any sort of application that has this information extraction step would be a good candidate for document understanding.
Awesome. Appreciate that. So when you say natural language processing, is there an aspect where you have to teach the machine how to speak our language, or is it kind of a combination of, machine language versus human language?
So natural language processing, and we shouldn't think of everything that's just very current right now with mimicking human speech. NLP is a field that is very mature at this point, and it has gone through some evolutions. It has had some very big breakthroughs in the last 5 years or so. And we shouldn't think of the machine acting like a human, but rather being able to interpret human speech in a certain way. So whatever is written in the document in a certain way. So if you can think of something that you would do via rules, then if I say my name is Natalia, then you would extract Natalia and say, okay, that is a name. But it can do something way more complex. So when we go into the actual algorithms, then it goes into representing the words in different ways, in mathematical ways. This is all in the background, this is all math. And it can then achieve much more advanced solutions than simple rules or string matching would be able to achieve.
Appreciate that. What are some areas that can leverage this document understanding?
Yeah, so we're looking at extracting key information from the documents for document understanding overall. And I did mention that it is a bigger umbrella, but I think that is one that's particularly relevant to healthcare. So starting off with maybe some areas that are not in healthcare, one big area for document understanding is invoice processing. So invoices come in a variety of formats, but they all contain very similar types of information. And so considering that there's different formats, then we're thinking, okay, well, maybe we need this computer vision component of document understanding, and combined with understanding the text within it, that's where the NLP comes in. But you can use document understanding to extract, like, what are the items that are being invoiced for? Like, what are the lines? What are the amounts? Who is sending it? Who is receiving it? And different types of information. Similarly, there's form processing. So whenever you fill out a form, there's always these field names or keys, and then you put in the value. So that's also a good candidate for document understanding, where perhaps you can train a model that would learn to extract all of these key and value pairs from a document that has explicitly stated keys. So it just depends on what it is that you want to extract. Document understanding, like the umbrella of document understanding, can be considered for that. If we go into perhaps the legal field, then we can use document understanding to extract key clauses from contracts, or perhaps understand different relations between documents in a case. For human resources, it could be used for interpreting resumes or cover letters. So these are, again, things that have different formats, but contain generally the same type of information. And if we go into healthcare, then there are many more applications that would be good candidates for document understanding. And this is where I could go way beyond the time limit of this session. But if we go back to invoices and forms, then we can think of healthcare back office operations. So processing of invoices, receipts, we can use document understanding to extract the key fields, the amounts. We can look at EOBs, the explanation of benefits forms. These come in different formats depending on who the payer is. But again, it's largely the same type of information. So machine learning techniques can be used to extract that type of information. If we think of all of the information that is stored in EHRs that might need to be printed or exported in some way, doctor's notes, medical histories, lab reports, there's any other kind of chart information, it might benefit from extracting diagnoses, treatments, patient demographics. There's so much that you would want to understand from these forms. And if you're taking part in a process where you're just constantly taking in this type of form, extracting some information, plugging it in somewhere else, and then continuing your process, that is all just a key candidate, a prime candidate for document understanding. So whenever, and document formats vary, and the document information is generally the same types of information, those are great areas to consider this. Now, one key case that I have worked on is intake of healthcare referral documents. So whenever someone has, or a provider feels that their patient might need to see a different provider, a specialist, perhaps for additional evaluations, perhaps go to an imaging center to have some sort of scan or test done, a referral document will be generated, and this document will contain information about the patient, the referring provider, the exam or procedure that is to be performed, and the reason for the referral. Now, the specialist or imaging center facility, whoever is receiving this referral, needs to extract information from this document in order to act on it. So they need to understand, is this a patient that's already in my system? Or is it a new patient that I need to create a new chart for? where is this referral coming from? What procedure is going to be requested? Perhaps some insurance information might be in there as well. So once all of that information is understood, then the correct documentation is created on the receiving side, and then the patient can be contacted for scheduling the appointment. Now, this is a largely manual task, but it is very repetitive. You're always looking at the referral and taking different types of information. Now, the document isn't coming necessarily electronically, just sending some key field values that go magically into your system. We are not connected that way. So it is still passing a document from one facility, from one provider to another. And we can think of the scale of the problem. So specialists or imaging centers may be receiving hundreds of these referral documents every day. And these documents just go through the same process, different formats, same process. So this is a very good area, or like a very, say, it's an area that could definitely benefit greatly from document understanding.
Yeah, I think anytime you hear the words manual, repeatable, field, value, those are the keywords that you can really automate. And I think what's lovely about that is those automations don't take opportunities away from people. It opens up opportunities so the patient can be the focus point. And, instead of, trying to get a fax document or a PDF and trying to grab that data manually, like you mentioned earlier, to reduce human error. But I think that's actually a good segue into the challenges of this technology, especially in healthcare, because there's no standardized template. Every facility is going to do things different. There's fax, there's snail mail. So how do you properly produce code to combat all of the variables and the various challenges there?
Okay, yeah, so in order to go into like what would be the solution, then we need to consider all the challenges. And you did just go over some of them. So we can think, instead of just straight out going through the challenges, we can think of like how is this problem traditionally solved, and what are the gaps there. So mentioned the referral intake process is largely manual. But there are some solutions. These traditional solutions are rules-based approaches. Now, the referring provider is the one who decides the template. I mean, maybe some facilities require all referrals to come in on their side, but for the most part, every provider has some sort of form they use for referrals. Print it out, send it, fax it, scan it, give it to the patient. It can be delivered in a variety of ways. Oftentimes, it is through fax, even though like we do have a very big reliance on fax nowadays, even though we have many other solutions. But we can think of, because there is no specific template, now a traditional solution might be looking for certain keys, so certain field names. Maybe they're looking for the word patient name, or maybe they're looking for physician address, date of birth, different kinds of fields that they might be interested in. And then start building rule sets around that. Now, a specific, let's say we take an imaging center or a specialist, they'll probably be receiving referrals from different providers. So they can also be looking at, okay, well, these keys don't exist in this provider's referral form template, but now I'm going to implement some rules. So looking at these specific pixel ranges in a piece of paper, this is where I expect the patient information to be. This is where I expect the physician information to be. This is where the procedure is going to be. And now you have to keep up with every single different template that you have. Understand what type of template it is, where does the data go, and then whenever those templates are updated, then you need to revise your rules. And if you're receiving from dozens or hundreds of different locations, then it really is a problem that's very difficult to manage and scale. So that's already a big problem. So rules-based approaches have severe limitations, and this process is often just done manually because of that. There is quite a bit to set up these rules and also maintain it. It's quite a bit of effort. Now, referral documents are also often faxed. So if we just had a PDF that got generated by a system and it can be sent as a PDF, and then we have a product to extract the metadata, then we at least don't have to deal with problems with the image, but that's not often the case. We still have a fax. The fax will, or even a scan, will turn the PDF, which is rich in the data that it has in it, and just flatten it out into an image. Now we might end up with skewed images or low resolution images that we have to deal with. We might faxes might just insert a vertical line into the page. And there are many we call them artifacts that can happen on this image itself. So overall, there are many challenges. We're looking at like inconsistencies in the formatting itself. So different templates, different formats, different layouts, different qualities of the documents that are received. And so all of that is what we would want then to think of, how can we solve this? So we don't want to use rules, but how can we create a scalable process? And there have been some pretty big leaps in some of these NLP and computer vision models. There's some combined models that exist nowadays that are state of the art and really allow us an opportunity to leverage them in order to kind of like move towards solving this document understanding for referral intake. So if we think of what would be needed, first you receive a fax, you receive an image. Now the first step is this image contains text. So how do I get the text out of the image? And that's where OCR comes in. So OCR is Optical Character Recognition, and it is a method that has been, I mean, this is a decades-old problem that has been very well solved. So there's products of different qualities that can take an image and extract the text from it. So like if you're trying to pay with a credit card, your phone might ask you to just take a picture of your credit card. OCR is then used to find the number in your credit card, input it into your application, move on. It saved you a step from and a potential mistake in writing the wrong credit card number. So we first use OCR. Now OCR is going to get the text out of the document itself. And that's great. Text is what we need for NLP, for natural language processing. And NLP, more advanced methods where we're not, again, just looking at string matches. NLP methods will allow us to be able to identify, say, given names. Names are words that are not standard words. Perhaps find patterns such as addresses. And also, if we look at the information in these documents, if we're looking at the exam that's being like asked to be delivered, so the procedure that the referral is for, or if we're looking at the reason for the exam, these are going to be procedures and diagnoses, which are also very special types of words, and NLP methods will be able to identify that. So within the field of NLP, like we can do quite a bit with that text, but it's not enough. So there's different layouts, keys, field names are not always there. And so now we need to think of, okay, I need something aside from the text. I need to understand the positioning of the text. And as just like humans looking at these referral documents, we can make certain assumptions. So if you see a big letterhead, if you see a big name and address in the middle, it's probably the referring provider. This is the template that they use. Their information is prominent. Their information is the same across every referral that they send. But it doesn't say referring physician, right? So it is just like our brain is able to make that connection. Same as the patient information might always be towards the top of the document. Like you want to know right off the bat, who is this referral for? And if you see a field name, like say you see the phrase patient address in your referral document, you're not going to look above it for the patient's address. You're going to look either to the right of it or right below it. So these are all things that our brain can handle quite well, but computers need to learn these types of relationships. And we don't want to be writing rules for every single assumption that we make as humans. So that's where the computer vision models come in. So By passing OCR, in addition to giving you the text, will give you the location of the words on the page. So by passing the location of these words as well as the image itself, we can use machine learning techniques that can again get us closer to that document understanding for referral intake. So now we have OCR, we have NLP, and we have computer vision. And if we combine all of this, then we are definitely well on our way to like the types of technologies that we need for document understanding. Now, these have been, there are state-of-the-art methods for doing document understanding with these types of techniques for receipts and invoices or form processing. Now, the solutions in healthcare are not leveraging these types of techniques. They are largely rules-based. Again, we've gone over some of the problems, scalability and maintenance being two big problems with these types of approaches. But healthcare is special. And often models, machine learning models that work in other fields don't work out of the box in healthcare. So we have found by looking at this problem that you need to include some information that is healthcare specific, perhaps some assumptions that we make that are specific to the healthcare domain, or how overcoming some of the challenges that these algorithms might face in healthcare type documents. So you had asked me about, well, what kind of like tools can we use? What kind of technology? So we have found that by using OCR and then also using models that incorporate both NLP and computer vision components alongside with some domain knowledge, we can really get or be moving forward quite a bit towards document understanding for referral intake. And that's the use case that I've looked at, but then these types of models will be relevant for different types of healthcare documents or different types of document understanding use cases as well.
Appreciate that. Yeah. It is interesting to see how you can do the technologies across industry, but even in my own experience, healthcare always seems to lag behind a little bit. And I think a big reason is HIPAA, PHI. So anyone that I talk to that's clinic facing, security seems to come up at some point in the conversation. So even with these challenges that are being overcome with technology, then there's the challenges of maintaining the patient information in a secure fashion. I think a lot of people use faxing because it's more secure in nature, although it's a bit antiquated. It's harder to get into a fax machine line and pull that data. So I guess a good question is, what are some of the things that are mitigating the risks involved with extracting that PHI and having it housed in a text format opposed to PDF format?
Yeah, so it would be just the same as having tabular data. So if you have a product, you're ingesting information in some sort of tabular form or some sort of metadata that can be stored in the backend. So if you're following all security standards for storing that data, then there really is nothing else to be concerned about. If you have a PDF versus the information from a PDF, you still need to make sure that it is stored securely, right? So that you do follow HIPAA standards, you follow whatever security standards are relevant for your process in healthcare and out of healthcare for some other sensitive areas as well. Yeah, we definitely don't want any patient information to be at risk of being released somehow, but then it's just the standard security processes that we would follow with any of our products, right? So we're not sending patient information. We're not putting these PDF documents into some free tool online, right? So everything is performed in-house with secure servers, and again, no back and forth that could potentially violate any security standard.
Appreciate that. Yeah, security is security regardless of the technology, and that's why we have those standards. Great answer. I think we have time for about one more question. If anyone has any questions, feel free to put in chat. I am curious, in the meantime, how you see this technology transforming, 5, 10 years from now, especially in healthcare. Like, what's the future state? What's the roadmap? Because I know you talked about combining various technologies, and as technologies increase, there's more of that. Like, how do we use
Mm-hmm.
this and that?
Yeah. So currently, what we found is that document understanding and for referral intake can be greatly beneficial for augmenting a person. It is not quite there at the point of automation. So we see a lot of state-of-the-art products. If you look at their results in the healthcare space, especially, then you're not looking at 100% accuracy or near it. So right now we're at a point where we can greatly speed up a human by highlighting the right information or like what the model predicts to be the right information, and also taking away that element of a human having to type in the answer. So we definitely want human error reduction to be a big component of this. Now, as we continue to work on these models, learn where the errors lie, and as technology continues to improve, we've already seen just like a big explosion in technology this past year with generative models, right? The technology, these are not generative models used for document understanding, but as we continue to see technology improve in different aspects, so these models that combine vision and NLP. So we have seen companies come out with models that skip the OCR step. Now they're not nearly as good for this information extraction task. They're good for other use cases, so not for referral intake. But we'll see research continue to progress, and the hope is that we can get into automating this process. OCR continues to get better too. So this, like, understanding skew and artifacts and maybe making some corrections. There's also improvements in like text correction, so perhaps getting rid of typos in documents as well. Ideally, in 5 to 10 years, we will all be better connected also. And so like some of these steps can be skipped, but we definitely are seeing great strides made in the machine learning field that could be relevant for document understanding overall.
Very exciting, very exciting. Yeah, I think the world has changed with the generative models you were referring to. The more and more people are talking to AI now, and it's fascinating to see how the landscape has changed and what that will do to benefit healthcare too. Right? I think already we have a lot of things in place that really puts the patient first and removes the need for that redundancy and that potential human error. So it's just amazing to think how much better that will be even 2 years from now, never mind 5 to 10 years. I do have one question in chat. I think we can close with this. Can this trigger an automation for a workflow?
So if the question is whether extracting this information could then be used to move on to the next step in the process, if a pipeline is built that way, then it could get to that point. As what I've been covering more is the general use case and the AI use case of it. So I think triggering an automation being you receive a document, you extract information, and then that information extraction would trigger a workflow. I can see that totally doable with the right pipeline built. But that would not then be part of the document understanding process. That's like what happens once we've extracted this information from the document.
Right. Possibilities are endless. Well, awesome, Natalia. I appreciate you fielding these questions and speaking so eloquently, and I'm excited to see where we go from here. Really appreciate your time.
Yeah, thanks for having me. I enjoyed the conversation. Thanks.
Likewise. Take care.